Hi everyone, welcome back to the second half of Chapter 3. So the next we're going to talk about weather and climate, and what are the difference between the two, and what controls the weather and the climate. So weather is short-term atmospheric conditions for a specific area, while climate is the aggregate long-term weather conditions. And so what do I mean by that? What is the weather today? It's sunny and warm. What type of climate do we live in? Dry, warm summers with cooler, wetter winters. So the weather is what is happening right now or what's going to happen at a specific day. So when people use a weather event, one weather event, to kind of disprove something about climate change, that's not really how it works. Climate is more of what are we expecting to happen in the long term. It doesn't mean we can't have some variation, but climate is more the average of conditions, right? So in San Diego today, while I'm recording this lecture, it is conveniently sunny and warm, which it so often is here. But generally speaking, our climate, we have dry, warm summers and cooler, wetter winters, right? Most of our rain comes during our winter season. So there are four elements of weather and climate. These are the things that make up our weather and climate and what we use to talk about our weather and climate. The first one is temperature, which is the most obvious. Here's a little snapshot from weather.com. On this day, it was 71 degrees. The next is air pressure. We're going to spend a lot of time talking about air pressure and how that works. But right here we can see over here that on this day the air pressure was rising. Wind, pretty self-explanatory. We all know what wind is, if it's a windy day or a calm day, and moisture content, which is humidity. And again, we will get into the specifics of all of these elements in later chapters, but these are the four elements of weather and climate. And next, I want to talk about the controls of weather and climate. What are the factors of physical geography that affects our weather and climate? And so I'll talk about each one of these individually. So the first is latitude, and we talked previously about latitude and longitude and how latitude is kind of important when we're thinking about the weather, right? If you're at a lower latitude, if you are closer to the equator, right? Lower latitude does not necessarily mean farther south, just closer to the equator. You're generally going to get more solar radiation, so that is going to affect your weather and your climate. Next is the distribution of land and water. And I'll talk more about this as well, but generally speaking, if you're closer to the water, even if you're at the same latitude, if you're closer to the water, it's going to have a moderating effect on your weather, which means it's going to be a little bit milder. So if we look at Seattle versus Fargo, North Dakota, they're at the same latitude, they have the same kind of average temperature, but the temperature range in Fargo is much, much more extreme. It gets way colder in Fargo than it does in Seattle. Next is the general circulation of the atmosphere. So the atmosphere is moving around above our planet, pushing moisture and air, and so this is going to affect, depending on where we are in this general circulation, it's going to affect our weather and climate. Also, the general circulation of the oceans. We have warm currents and cold currents. California is by a cold current, and we'll talk about these currents more later in the semester. But this can have a big effect as opposed to, so here, get my mouse to come up. Here we go. So here is our the cold current going by California, and this has a nice cooling effect as opposed to these warm currents that are coming up here, which has a warming effect on parts of Asia. The next is topographic barriers, and again, we'll go into these more and more as the semester goes on, but here is a map of the big island of Hawaii, where you have trade winds that are coming in that are bringing lots and lots of moisture, and lots of rain. So on the east side of the island where Hilo is, you're going to get 150 inches of rain a year, which is pretty extreme. But But on the other side, you're going to get much, much less. In Puako, you're going to only get 9 inches. This side of the island is very, very dry. This side is very, very wet. And that's because this moisture is blocked from reaching the side of the island by the mountains in the middle. And the next is storms. And so storms, later in the semester we'll talk about hurricanes and cyclones, but obviously those don't form usually where they have the most impact. They kind of travel across an ocean. So this is Hurricane Hermione hitting Florida, but obviously big storms will have large effects on your weather and climate. Next, what you're going to do is watch a very short video on the Coriolis effect that is going to explain it much better than I can. But this is a little easier to explain in a classroom setting, but because we're online, I can't have a globe and be moving things around. But the basic idea is that the spinning of the Earth, right, the Earth is spinning below the atmosphere. The atmosphere is spinning with it too, but not at the same rate. And so things are deflected because of this spin. It is why our storms also spin around. And so you're going to watch this short video to get an understanding of the Coriolis effect and how it works. And you're going to want to make sure that you have a good understanding of this before you proceed on to Chapter 4.